Hello everyone, a very good evening. Welcome to Data Science Demo Session. My name is Ashok. I'll be your host for today's session. I see participants are still logging in. Meanwhile, we can start our introduction. So I would like you to introduce yourself. So I would like to know your name and your experience, how many years of experience you have altogether, exposure to data science, if any, and it would be nice to know your city as well. Where are you from? Currently, where are you from logging in? All right. So I'll start with Kishore. Kishore, you can unmute your mic and introduce yourself. Yes, please. All right. Thank you for introductions. A quick introduction of myself. My name is Ashok Kumar Adinarayanan, and I live in Amsterdam and Bangalore. Amsterdam is my base location, and that's my email ID and my LinkedIn profile, and of course my Twitter tag. So I'm a data scientist, business consultant, and project manager, and an entrepreneur. I've been working in Netherlands for past 8 years. I have overall 15 plus years of experience. Worked in different companies including HCL, Logica, CGI, in various roles like project manager, business consultant, etc. I'm currently working predominantly on data science related area. So I'm a lead data science consultant, and also I deliver trainings. So I have managed a large scale projects for European Commission back in 2007 to 2013 in Netherlands. And all these projects are innovation projects, smart city projects. So I'm a MBA degree holder from IIM Ahmedabad, and the focus is international business. That's from India. And another MBA from University of Amsterdam with a thesis in business analytics from Netherlands. All right, so let's move forward to our topics of the day. A quick agenda here. So we'll start with what is data science, and then we'll move into various types of business analytics or various types of analytics or data science models in practice. We see a couple of applications of data science, which is right now industry, or how the data science is being used in the industry to give an inspiration to understand where are we heading to with the data science. Visual analytics, we will actually take a Tableau example, and I'll demonstrate how a visual analytics can be helpful in getting a meaningful information or insights from the data we have. And we talk about a little business statistics. We're not gonna go into any definitions. We'll just see the topics of business statistics as it's a demo session. We'll have a quick tea break, and then we discuss about machine learning, and a very interesting topic. And we talk about different tools and platforms and programming languages we use for data science, and a quick discussion on roles and career paths, which is I think it's one of the things you're looking from this demo session. And training itself, how will be the training and the certification, what is the different kinds of certification, how it will fit into your profile. And of course, at the end, you have a Q&A session, question and answer session, and it's your time. You can ask all sorts of questions. I'll be happy to answer them. All right, shall we start with our first topic? So what is data science? So this is a Wikipedia definition. Data science is the interdisciplinary field about scientific methods, processes, techniques, and systems to extract knowledge or insights from data in various forms, either structured and unstructured. It is kind of similar to data mining, like previously discussed data mining. So this is a definition. So what do you mean by that? So we are dealing with a huge amount of data and scientific methods to extract insights from this data. Okay, it may not really very clear look at the definition. But when you go ahead and do the data science hands-on modeling, then you understand what you mean by that. It's a very broad field, and most of the time when you say data science, we should also specifically say which domain. Are you a data scientist in a particular domain, for example, healthcare, etc.? Because data science, in order to really get a meaningful insights from the data, you should be a domain expert as well. And this is a quick evolution of your data science. So previously, long back when the computers first entered the business world, we have something called as mainframe system. You remember a huge computer where you have all the data being stored. I'm sure even nowadays some legacy systems are using mainframes even today. All right. And obviously these guys have to learn and move on, because very soon this mainframe is going to be absolute. All right. And all the data is stored in the mainframe. But as we progress over years, the data from it is not possible. It became like we are more towards distributed systems or distributed computing, whatever you call. And the company itself, actually companies, organizations become multinational companies having different regional head offices and systems and infrastructure. The data is being distributed so widely, right, and captured so widely, it become a huge challenge to actually get all this data to create a meaningful information, meaningful insights, right? So if you want to understand what is the company's sales overall, including all the regions, Americas, for example, India, UK, whatever, right? Different regions, China, maybe they're doing this in China, it becomes a really big problem. And this problem, we call it as islands of data problem. Islands of data problem. So when we moved into distributed computing, the islands of data problem, basically your data is in different locations, become very prominent. And that actually led to your concept of data warehouse. It's early 1990s. So we have conceptualized data warehouse. It is a huge data center where you capture the entire company's data from all the different divisions, different regions into one place. Well, we're not going to copy the entire data. We're going to take selected data from all these regions and you put it into the data center, data warehouse, DW. This is what we call it as data warehouse. And as we have all the data in one place, we run certain applications. We call it as BI applications. If you know Cognos and many other applications, right? So these BI applications extract data from this data warehouse and create some meaningful information or insights for the business. We have a lot of challenges because there is a lot of delay capturing this data, and also it's selected data, which means that may not reflect the whole data, and it is asynchronous, means that you're not really capturing data in real time. We don't have that. Sometimes it might have days delay before we gather all the data and create a meaningful report. Even now, business analytics is very prominent, business intelligence, sorry. And we slowly moved on to a terminology called as data mining. So we started to dig into the data we call it as mining data and create some meaningful insights of the business. This data mining has been there for past 5 to 10 years, near to decade, and slowly we have moved and coined the word what we call nowadays called as data science or analytics, which is much more powerful and much more dynamic. It can actually scroll to structured, unstructured data. It can do a lot of other things. Even it can predict the future opportunities and future potential for a business. Right? We will see how it does it. There are a lot of algorithms and methods to do this. That is the whole purpose of the data science course. Okay, this is a quick evolution. I understand I messed up the where is it? So this is the evolution of your data science. Any questions? You can just type it down in the chat box. I'll be more than happy to answer. Okay. And that was a very quick introduction. There is a few hours of story about data science evolution, because as a data scientist, you are supposed to know what is the whole history, what's the evolution of data science. Okay, and you might heard about people talking, referring to business analytics. Okay, and also data science. So what's the difference? Anyone here can tell me what's the difference between business analytics and data science, or is there a difference, or it's the same? Anyone? Praveen? Joseph? All right, Rina is saying business analytics is, what is that? You can unmute the mic and speak out. It's better. All right, okay. All right, so okay, cool. So, well, business analytics is mostly focused on business questions, or simply put, trying to find insights or answers. I'll put it in simple terms as of now: answers to the business questions from data. So it's very focused, and the complexity is actually low. Okay, we're not going to create some new models, but we're going to use the existing whatever framework to extract meaningful insights from the data to answer a particular business question. We will see that when we are dealing with the visual analytics, I will show how we can answer a particular question. I'm sure we will have time for that. Whereas when you talk about data science, it's a bit broader field. We are more seriously looking into data science models, algorithms, creating the data science models, which can be used by business analytics guys to predict the whatever. It's more like creating, as it says, scientists, you are creating new models which can be reliably used for the business purposes or research purposes or whatever it is. So data science is a much more complicated and a bigger umbrella. Okay. But for most of the practical purposes, if somebody is calling this work as that and that work as this, it's fine. But just keep it in your mind that data science is much complex, and it is more a scientific way of dealing with the data and creating data models, and also it's more reliable in terms of long term. Whereas business analytics is more about finding answers short term, like finding answers to the current business questions, and the complexity is usually low. Okay, we will deal with the detailed information, differentiation and different models in a full class. All right. So even when most of the job opportunities in the market, when you say, all right, so it's mostly we are dealing with business analytics related jobs. Most of the jobs, right? So creating the models are relatively less, very highly paid and very highly respected jobs. But the volume jobs, the majority of jobs in the market are mostly in business analytics. They also call it as data science jobs. Nothing wrong in that. Data science opportunities, but yeah. And you might heard about lots of terminology in business analytics. Somebody says descriptive or predictive or whatever, right? So this slide is specifically focused to demystify, to give you a clarity on what are the different types of business analytics and what does it actually mean. We'll start with the first one. The first model is descriptive analytics. So when you say descriptive analytics, so we are talking about digging into the data of the current present data and the past data and create meaningful insights for business. So it's basically, this is focused on analyzing the current data and trying to see what happened, why it happened. Okay, that is what the descriptive analytics is. Whatever analysis you are doing with the data as of now can be simply labeled as descriptive analytics. For example, you're looking at what is the sales for this quarter, right? A company is looking at the sales of this quarter and maybe different segmentation, which region has performed better, which product has performed better, and this is all nothing but your descriptive analytics. And most of the companies do descriptive analytics in one or the other form. The second one is your predictive analytics. It's a little more interesting one. So what is predictive analytics? Predictive analytics is trying to predict what will likely to happen. So it's going to predict the future directions, future opportunities, future trend of the market, or maybe your own business. Right? This is much more interesting. Now we will see in more detail how it predicts based on the current data. Okay. Then we have discovery analytics. It's a kind of prediction, but discovery analytics more focused on finding patterns within the data. So we are not formulating any questions here. We create algorithms which actually goes into the data, try to find the repetitive patterns which might be very useful and meaningful for the business decisions. All right. We will see in more detail about that later. And then we have the prescriptive analytics. I can tell you these three analytics, the descriptive and the predictive and the discovery, becomes an input for prescriptive analytics. What do you mean by prescription? Your algorithm, your model will prescribe. You know what is prescribed? When a doctor gives you a prescription, if you have to really follow that. Otherwise, he cannot guarantee anything about your recovery, health recovery. Okay, so you have to follow that. It is like prescription. So they have done the analysis. Just do this. That's all. Don't ask any questions. Prescriptive analytics is similar. So it's gonna go through all the information and it will churn and it'll tell you, right? You know what? Launch this XYG product in next quarter. It's gonna be a huge success based on so many internal and external industry parameters. It has done all the math by itself. Okay, this stuff is actually done by your CEO, CTO, all the senior management guys who are sitting at the top. From their experience, from their gut feeling, sometimes they take these decisions. But if you have a prescriptive analytics, really, which is the highest form of analytics within your organization, well established with the right measurements and right models, it will tell you what should be your next business move. Well, that will be fantastic, isn't it? Right? And a company which has a very strong prescriptive analytics being adopted, we can say that it's an evolved organization and which makes decision driven by analytics. Okay, so please remember the terms in a higher level. Descriptive analytics is about current data, present data and the past data to understand how are we doing. Okay, and predictive analytics, it's about predicting what is likely to happen. So it will really helpful to make some business decisions to make the business more successful. Discovery analytics gets into the patterns and tries to find the repetitive patterns which is valuable for the business. Prescriptive analytics is actually at a very high level which takes all these inputs and tell the business what should be the next move. It prescribes the next move. Okay, and a company adapting prescriptive analytics can be called as evolved organization with decisions driven by prescriptive analytics. Alright guys, any questions on this? I understand I'm moving fast because I want to cover so many things in demo itself. Okay. Alright, thank you. Okay, I just added one more slide to show that people saying that, well, big data is nothing but data science and data science is big data. Well, they are two different things. Big data deals with huge data, huge volume and the velocity, the rapid velocity of the volume, the data, how fast the data is coming in and what different kinds of data, variety of data. We call it as 3 V's, right? These 3 V's are big data. This is a big data Venn diagram. It deals with 3 V's. Whereas data science has a different thing. Data science require hacking or programming skills to actually bring data from different sources. That's a foremost thing. Data science starts from where you get the data. And the quality data, right data for your analysis. That requires hacking skills, what we call as hacking skills. And then you need a business or domain expertise because we are creating insights or we are making the business, suggesting the business what should be the next move. So if you don't have a domain expertise, you cannot really formulate, you cannot do anything with the data. You should have a domain expertise to become a data science, to do any data science work. And of course, data science heavily relies on statistics and mathematical knowledge. So this 3 is called as data science Venn diagram is entirely different from big data. I put it next to next for your comparison. And we will actually go in deeper in the full class on this. All right, so that's all about your first topic. What is data science? Hope it was, at least at the higher level, you understand and you get an idea of what is data science. Moving forward, are we okay? Is it a good phase? Well, data science is a very long course. We go about 30, 35 days, sometimes 40 days. So we actually take things slowly. Initially, it looks like your brain is really feeling that it can't take anymore. But as we move on, it becomes easy, right? We become more data friendly or data science friendly. And then most of the concepts will go easily. So if you have any doubt, you think I'm going a bit little faster, we can skip some slides and at least cover whatever we want to cover in a more detail. All okay? Oh, that's fantastic. Everyone is saying it's a good phase and interesting. And our third topic is actually interesting topic. We are talking about data science applications. Last month, like few weeks ago, I think. So we have a research being published from a University of Nottingham. Right? They have proved that artificial intelligence predict heart attack better than doctors. It has been proved, and it has been published in Harvard Business Review. The link is given over here, and also in another credible source, Futurism, with a clear information about how it actually works. To give you a rough idea, it basically consumes all the thousands of patients' data who got attacked by the heart attack and their previous parameters, and a proper training of this model will become so strong that if you give you parameters, if you give what is the blood pressure, cholesterol levels, and age, and the gender and other things, and maybe the race and other things, it will tell you how much chances that you get heart attack today, next year, 5 years, 10 years. So it is much accurate than any doctor can tell. So this is being already proved, and it is already in trials in many of the research centers across the globe. I have done some health science analytics back in Netherlands, especially for a few of the clients. I cannot reveal the names, but it's very interesting. Analytics, data science is taking main stage in healthcare. You find this interesting? All right, okay. The next application, I just picked up few applications from last 2 weeks reporting, because every day you see that data science is being used in a different industry in a successful manner across the globe. So all the examples I picked up are just a couple of weeks ago. This is about finding criminals. UK police is using artificial intelligence system to actually identify or classify offenders, whether they are low risky, medium risky, or high risk offenders, so that they can take a decision whether to keep them on custody or not. It is being already used. And also there is a police division from Rajasthan, India. There's a link given over here. I'll share this video so you can actually go through these links and understand and know more about these examples. Indian police, Rajasthan, is using artificial intelligence to determine the criminal offenses, register the criminal offenses. It's one of the huge applications. And the third application is about, of course, retail. Amazon is going crazy with all kinds of models to make people buy more and more. You know, I'm sure you have the same problem as I have. I have 3 BHK apartment. You know, we are nuclear family. Me and my wife and 2 daughters. But we have 3 BHK. All we sleep in 1 BHK. So why we have 2 BHK? Well, another BHK for office maybe, and one full bedroom is entirely for shopping stuff. You know, I should not say that, but I'm sure everybody has a similar experience. We buy things even though we don't need it because it's just a good offer. We have 70% discount, just buy it. Don't even think whether we need it or not. So these retail guys kind of influence you to buy stuff. How they do it? They use all kinds of data science analytical models to influence you. Okay, there are the few applications here. And apart from influencing customers, they also use data science models to know what to stock, how much to stock, and how to suggest products for the repeating customers, etc. etc. You can see a couple of there is a McKinsey report on that, how retail is getting competitive using data science, and also there's a Forbes.com review on retail industry using data science. I put these links to you. These are all just 2 weeks links. These all reports are just 2-3 weeks. Next month I'll be having a whole set of new examples, because that's a phase of analytics being, like the data science being evolving. HR analytics. We have done a project recently for one of the clients in India. So we have created a model where, given the parameters of what's the experience, what kind of skills you have, what's the gender, which kind of companies you work, we can tell whether this employee will work to the full potential, he'll be a productive employee or not. How you do it? Well, we train the model using historical data, because we know all the data from the past 5-6 years, all the parameters or the profile information when they join the company, and we also have information who are the best performers in the company as of now, including the locations. So we can use this data to train a model, and when a new resume comes in, just give that resume information to this model. It will tell you whether this guy will perform or not. I don't say that you hire it directly from it, but at least we can cut it down from 10,000 resumes. If you want to hire 50 people and you roll the notification outside for the job opportunity, so you get some, let's say 10,000 applications. It's a very nice job, right? So how do you actually you can't really reach 10,000 jobs, right? So if you give it to this model, it will maybe filter it down to 100 maybe, or 200. For those 200 people, you can conduct interviews and take 50 people. So that's really helpful. It cuts down the HR cycle. It also makes your company more effective, because company is all about human resource, right? What you have, human resource, processes and tools. This is the company, any organization. Human resource actually is very major part in any company success, right? If you hire the right person using analytics, that's going to be a huge success, very valuable asset for your company, right? That's HR analytics. Analytics are also used to predict other diseases. We talked about heart disease. Right now, this is skin cancer, right? So you can just scan a skin, and this image will be processed. It is compared with some millions of images which has been already detected as skin cancer, and can tell you whether you have a skin cancer or not. You don't have to run any biological test. Just looking at the pattern of your skin, you can tell that. So how cool it is. And this is also live. It is not something experimented. It's also live in the market, especially in US. Skin cancer detection is done by artificial intelligence or machine learning algorithms. You have recommendations. See, if you buy something in Amazon or any retail shop, you see that after you buy or maybe browsing through it, you say frequently bought together. So where this is coming from? This is coming from a machine learning algorithm called as association rule or recommendation engine, right? It basically looks into that the patterns of purchase, and when you go to there, based on the previous other customers' purchase pattern, it will suggest you something which makes very good sense. Most of the time, you'll say add all 3 to the cart. So it's increasing the sales from a particular customer. Okay. This is also machine learning algorithm. And of course, your facial recognition, it has already been deployed in many places, even in retail shops. If you go in US, there are some shops where it will identify you, who are you, where you're working, what's your profile, and it can suggest you what kind of, maybe you can just send a just notification, WhatsApp message saying you have 30% discount on so-and-so product. What product to suggest? That is decided by based on your profile. And how do you know you? Well, you are identified when you entered the shop. Facial recognition. This is also live in many places. This also comes under your image processing and one of the machine learning algorithms. And there are many more. There is no end talking about this. So moving forward, most of the applications data science will be playing industries, and most of the career paths, data science becomes kind of mandatory. Right? At least the knowledge of it. If you're working in data science, then you should be an expert. And if you are not working in any directly in the data science related, you should be knowledgeable about it. All right. So visual analytics with Tableau. So far, so good. Anybody feeling I'm moving fast or things are not clear? You can just speak out or just ping it on the chat box. Visual analytics with Tableau. Okay, so I'm going to just directly go to the Tableau. I don't have Tableau, okay? No, I have, okay. So, okay. So one second. Okay, so I have connected to one of the clients Google Analytics. All right, so you know Google Analytics, right? So if you link it to a website, it will capture all the website's data, who is coming from which location, how much time he's spending on the website, and all this web analytics, if you want to say that, right? So this is I've connected to one of the Google Analytics live data. Okay, and I have a few measures and few dimensions. I'll just show you how quickly we can analyze the data and get some meaningful information from this. Okay, so let's see. I want to see how many visitors actually came to my site. I'll just pull it here. So I have this 1 year data, last year data actually. 4,40,000 visitors who came to on my website, who stayed more than 2 minutes, I think. Because if you don't stay more than 2 minutes, Google Analytics will take it as bounce, right? So they will not be considered as visitors. So these are the real visitors, 4,40,660 visitors. So this is I just pulled it, I see the number. Okay, then I want to know where are they coming from, which city are they coming from. I'll just pull the city dimension over the column. I'll just say add all the members. I have all the cities in the world wherever I have a data. This is, it is not really helpful, so I just click here to sort it out. Voila, I see a sorted out city list where Bengaluru is the topmost one. The company is actually from Bangalore. So we have 1,37,000 people visiting from Bengaluru. And then next one is Chennai, and then Hyderabad, New Delhi, and I don't know this null, which means the city is not being captured. All the not captured cities are showing as null. Mumbai, Pune. So all the top cities we have. And then you have London, and then Dubai, and then Kolkata, Gurgaon, Noida, Sydney, Moscow, Kochi, Melbourne, and some weird names which I don't even know, Singapore, etc. Okay, these are the patterns. So just looking at it, I'm able to analyze what are the cities my visitors are coming from, which cities my visitors are coming from. Taking this one step forward, I'm only interested in the cities who have more than 4,000 visitors per annum. Anything less than that, let's say, yeah, more than 4,000. Anything less than that, I'm not interested really. It doesn't make sense. Let's say more than 3,000. So I can just pull city into the filter and say, not the city, sorry. I'll just pull visitors to the filter and say, sum the visitors and say at least I need to have 3,000 visitors. Anything less than 3,000, don't show it to me. And here we go. So it only shows me the 3,000, more than 3,000 visitors. It's a quick report. I can just export this report, send it to my management. If they want to take a look, I can export it as a data or an image or a Grasstop. Basically, Grasstop basically have the similar kind of data, more like a pivot table. All right. I can even dig further. I want to know which are the sources I'm getting. When you say sources, people will just Google and search on the website and come there. Some people click an email and come to here. Some people go to a paid ads, the Google ads, if you know, anybody knows it. So click it and come from there into sources. So we have a default channel grouping over here. I'll just pull this default channel grouping into the colors. And like this, I have the entire structure. So from in Bangalore, where we have 1,37,000 visitors, out of which 76,000 visitors are organic search. Basically, they are searching in the Google search engine. They found our website and they're coming in. And then we have another 29 or 30,000 direct visitors. They are the people who are typing in the URL and they are visiting in. Okay, and there are some other paid searches. These are the people who are clicked into the Google ads and come to this place. And there are other referrals. If you have other websites which is placing this link, for example YouTube and so on, and these are referrals. So I just can see on glimpses what are the channels contributing to my website visitors. Okay, this is that easy to create, and I can make some business decisions. I'll see, is the money putting in is useful or not. For example, Bangalore, my paid search budget is, let's say, 3 lakhs or 2 lakhs per month, and I can do a quick math. This is 12 months, right? Roughly you take 12,000. So per every month we have 1,000 participants 1,000 visitors coming to the website. So we can do a quick ROI calculation to see whether it is making sense or not. Okay, this is one, and hope you understand. Any questions here? Just see how it is working, because I haven't really went into detail, so you cannot do it by yourself if you are new to Tableau. If you're already used to Tableau, then you understand it, of course. So I'll take another sheet, and okay, there's already something here. So I want to know the same information about the distribution on a map. So I want to see it on a map. So I will take a city and visitors, and I click show me and take a map. So it is showing, it automatically goes to India because India is the largest contributor, but it also has other regions. For example, let's say US. I'm sure US also has some potential. Yeah, it is still populating data. It is collecting the data, and it is trying to calculate and put the dots in the right places. Okay. Only shows India. Okay. Okay, let me see. Unknown geographical. Okay, there are 2000 values unknown geographical, but we have other. Let me just take off this filter. Maybe that is affecting it. Is that affecting? No. One sheet cannot affect the other sheet. Okay, just to show you quickly how we can look into it, and you can see these are the numbers. Okay. And within no time, I can create a geographical map, and I can even create a different map. This is another map where let me take a new sheet, because that seems to be having a problem. So I'll just click this one. Country and visitors. Okay, so I have a cluster of countries, and it is still populating. It's a bit slow. My Wi-Fi signal is slow somehow, so it is on the slower side. It is populating data. Yeah, this is working. This should also work. Take this off. Okay, so here we have the countries data, and I will take a different scale here. I don't like this color, so I'll just take brown color. So it basically, if we go to dark brown, it says more visitors coming from this region. Goes to the light side, it becomes less. So India is more prominent, as you can see. But just looking at this, it doesn't make any sense to me, because I already know India is prominent. So I want to analyze regions. Let's say my management, the client asked me, what are the different other countries except from India we need to focus for next year to increase our business? So one of the best ways to do is, what is the current visitor strength to our website from different region? Based on that, we can make a business decision. All right. So what I can do is, I can go to the filters and take off India. Okay, just take off India, so that it will focus on other things. So I have taken off the India. Now it is saying that if India is taken off, the next potential area is your, of course, US. This is US. We have 20,000 people coming from US, and then Russia, and then UK, and then Saudi Arabia. You also have Saudi Arabia, Emirates, UAE, all this Middle East will have another 15,000, and Australia. These are the 4 regions where I can focus. You cannot directly take this data. We have to use our own knowledge as well. I am doing with this client for a long time, so I can tell you, Russia, the number of visitors coming from may not be real visitors. They are the chatbots. Like, they're trying to ping your server, maybe to hack it, to get it down. All right. So these are so they are not real visitors. So we can discount this. So I'll send a report to the management saying that maybe with this diagram, so UK, US, Middle East, and Australia. If a management says what is the one country I would like to focus, that would be US, because we already have significant visitors coming from United States. Okay, great. So this is how you can make lots of, this is just a very high level information. You can also create calculated variables, derived variables. We can create dashboards. We can create animated live dashboards to show the information to the client on a live. Like when something happens, it is lively shown on your data. The graphs will live move up and down to give you a real feel of how the business is happening. That's all possible with Tableau. This is, we call it as visual analytics, right? Any questions? Going back to the slides. So Tableau we cover in 6 to 7 days with all the modules in more detail. Then we have business statistics. Yeah, I understand. Statistics is one of the boring part in data science, but you need to know a minimum required statistics to actually perform as a data scientist, right? So we're not going to learn the complete statistics. We have certain things. For example, we look into different types of data, and we look into different theorems, and we look into some analysis, and that should be good enough for statistics. It will take like 5 to 6 days time to complete, or at least 4 to 5 days time to complete and master the statistics as required by the business analytics or data science. Many people are afraid of statistics, but I can tell you a minimum math knowledge is enough, because we are not going to dig into the theories and all these things. We're going to use only the application of statistics. So anybody can understand and learn to an extent you need as for the data scientist. Okay, so we'll take a quick break. Okay, I'll be back in 10 minutes. Any questions before the break? All right, no questions. Sure. So take a break of 10 minutes. We'll be back. Thank you. All right, welcome back. So we'll have a quick discussion on a few things, which leftover things, and wind off today's session. The first topic after the break is machine learning. So what is machine learning? Have you been exposed to machine learning and know what is machine learning? So machine learning is basically enabling machines to learn without being explicitly programmed. It is very similar to how we learn. We look into the data or different patterns and try to store them, and we do the interpolation, extrapolation, and then kind of like come up with outcomes which is required for different scenarios. So I mean, these are the terms we use in artificial neural networks, and there are other algorithms like classification algorithms, clustering. We will see in detail about machine learning. So there are different algorithms. It's categorized into supervised learning and unsupervised learning. So when it's a supervised learning, you basically give them a data and you train them, right? So and again, in the y-axis you have categorical and continuous. Continuous variables are like the numbers. They are they can be multiplied, they can be averaged, all this kind of things. When you say categorical, they are like female, male, true or false kind of things. So they have different categories. It cannot be averaged and so on. So you cannot say 0.5 gender, right, as such with the data. So those kind of things are categorical. So in supervised, you have regression, decision trees. Random forest is also advanced decision tree, right? That comes under continuous supervised. And in categorical, you have KNN, K near neighbors. When you say KNN, it's K near neighbors. This algorithm takes nearest neighbor distance, and K is the distance actually. And it's a very simple algorithm, but very effective. We have different trees, and we have logistics regression, and you have naive Bayes. Naive is innocent. So because it ignores the relationship between the parameters, that's why I call it as naive. Bayes is a scientist's name. Naive Bayes is also an algorithm which we use for supervised learning. Unsupervised, you have clustering, dimensionality reduction. Categorically, you have association analysis, and you have a Markov model. We will see each and every model. We run them. If time permits, I can run a couple of the models. Let me see. What is the next slide? Oh, we're talking about tools here. So let me see. I think my R is open. Okay, cool. All right, so I'll try to find a script. So we have our scripts. We have so many R scripts. Sorry, scripts. Sorry, R scripts. My apologies. Yeah, we can take this pyramid neural network model. Yeah, let's take that. So this is it, a pyramid's neural network model. So this is an R file. It's a neural network model. Okay, it's a machine learning. So I'll just quickly explain you. I don't expect you to understand everything in this because it is just to show you how you train, how you'll be trained in the real class, right? So if you don't understand anything, just ignore and just try to understand the high level information. So I'm running the first line. It will ask open a file, select a file. So I'll just okay. I will go to Google Drive and sorry, so I'm not very prepared for this. Okay, so this is the concrete data. The file has been loaded. You can see here. So this is the file. So this has 1000 records, as you can see here. And what is this file? It's a collection of all the data about a strength of a pyramid. I mean, you can simply think as a structure, a building, right? So these are the different parameters of combinations we use while constructing this structure. We use this much cement, this much slag. You know, the slag is we add it to the cement to make it stronger. Ash, water, superplastic is a kind of material. Coarse and fine grack is basically the stones. We have a bigger stones or smaller stones, concrete, if you understand. And with this combination, after 28 years, the strength of that particular pyramid or structure is 29.89. In the similar manner, we have 1000 data records showing different combinations of cement, slag, ash, etc., and trying to see how after how many years, what is the strength of that particular structure. Okay, so I'm going to quickly select all the things, run it at once. So the way we do is, let me run till here. So it's going to quickly run all these things. Completed. So we break this 1000 set into two sets. One is like up to 773 records, and from 773 to the end of the field. So like 2/3 of the data is used for training a model, and 1/3 is used for testing it. So when you're training it, what we're doing is we'll give all this information to the neural network model so that you will understand what kind of combination is giving what kind of strength. Just like we will show the plot how it works. Right. After that, we only use 2/3 of data, right? So after that, whatever rest of the data we use for testing it. So we will give all the data, but we will not give the strength, and we will see how accurately this model is able to predict the strength. That will give you accuracy of the model. If the model is accurate enough, we will say anything 90-95% is more accurate enough. We can actually use this model for real-time applications. Let me just run this further and see. I'm going to create a model. This is a model. Neural net is the function. Formula is strength is proportional to cement, slag, and all this combination. All right. And I run this, and it is running. As you can see, the symbol over here. It is a simple algorithm with 1000 data, so it will not take much time. Right? If it's a very complex one, it goes into millions of records. Sometimes we move to Python. R has certain restrictions in terms of data. Of course, it can handle huge sets, but if it's so big, it takes so much of time. Then we actually move into Python. Python is much more efficient handling larger sets. I'm plotting this diagram. So this is how it looks. So these are the inputs, and this is a neural network, this is a neuron, and then this is the strength. So given the other inputs, right, it should be able to predict the strength with this model. And I have also written a 5. Okay, this is a 5 model neural network. So I have, let me see if I can run that as well for you. Okay, so it's going to take much longer time because it's 5 hidden neurons. So you can see this. As the complexity goes up, the time it takes goes exponentially higher. And this is why we have different tools. The reason we have Python and R is very user friendly. But if the data sets goes really massive, right, you have to move to Python or Anaconda where you can do bigger sets. Now it is done now. I can go ahead and plot it. So now I have added 5 more neurons. Neurons is just like your neurons. You are, the real neurons in your brain. So 5 more neurons. This model becomes much more accurate. Okay. And given the inputs, I have, I think, information. So I have given the inputs here. So with this cement, this slag, and etc., it can find the strength. So where it is used? Well, if this model is, if the data is correct, right, if the whatever data we have inputted is correct, the model is trained well, then we can use it for many purposes. We can use it even for licensing or giving for the regulatory bodies. Let's say you have the government regulatory bodies which will give license for the structures. It can be used for 50 years, 60 years. They can use this model and clearly give the license, because as of now they're giving from their previous data and experience may not be accurate. Sometimes a structure might stand for 100 years, but on the safer side they only give it for 60 years, right? Sometimes a structure with some weird combination is only capable of standing for 40 years, but the license is given for 100 years, which means that it's going to demolish at one time. It will cause some huge problems. You can have the accidents might happen, right? So this simple model can predict the strength based on the previous data. This is one of the application of neural networks, and I just showed you to show how we actually run. When you are taking a real class, each participant will be creating his own models, and all these statements are not that difficult. It might look a little scary, but few commands, and we keep on using again and again. As a data scientist, programming skills is required, but it is not that difficult. Anybody can learn that. Once you know it, you can create models by yourself. You can predict a lot of things. Most of the data, for example, I see a lot of people are from India, Bangalore, and few from US, right? So if you want to predict what will be the water levels or maybe temperature of Bangalore in next 5 years, you see a lot of speculation from newspapers and TVs and environmental guys, but you can also do your own modeling. You have 30 years historical data from the Bangalore government website, india.data.gov.in, something like that, right? You take it, you create your models by yourself, and you can predict the future temperatures by yourself. That is just for your own confidence and interest. But there can be a lot of potentials. We can do a lot of predictions, and also we can create models which is useful for the real business case. We have some more things here. For example, there is a bank loan thing which will actually take all the information and tell you whether this guy can get a loan or not. We have a fraud analytics, credit card analytics related things. We have so many other algorithms. Okay, so we have close to 20-25 use cases which we actually use for training people, and also we share all this data to you so that you can practice, and we encourage you to create new models. Some of the models I'm using is actually created by my participants in the previous sessions. So we use a lot of tools. Mainly we use R and Python, but we also use Anaconda. It's a new package. Anaconda is a next level of Python. So you can call Anaconda as Python for data science. When you use Python, it is a very generic one. So we have to download related data science packages and install it. Anaconda comes all installed. So Anaconda is much more used. Nowadays I'm using Anaconda because it's a Python for data science kind of thing. All right. R is heavily used. What you have done is actually R. Apache Spark is really picking up, and it's been used many places. Tableau we have just seen. R Shiny looks very similar to Tableau. It's coming from the R Studio, right? The same R Studio guys have created R Shiny. Tableau has a huge licensing fees. R Shiny is a free one. So R Shiny we can also play with it. Kaggle is from Google actually, which provides data and all the use cases. My apologies. And we also have R Studio, which we just used. Jupyter, it's a notebook or like R Studio for R. Jupyter is for Python. It gives you an interface to use Python. Okay, these are the tools we touch. Right. Any questions? That is just to show that you will be getting hands-on experience. I'm not expecting any questions from the model you have run. Well, in a real class, yes, we'll be getting into more detail of that. We have different roles in data science. One of the typical roles we are looking at nowadays, because there is no industry standards as such, these are the things I have collected from various sources, job portals, and it's kind of becoming more clear now what are the roles within data science team. All right, one is data science developer. Right, data science developer or they don't know much about the business and algorithms and other things, but they can program very well in R and Python. So given the model requirement, they will do the programming and get whatever things done. They're called as data science developer. They'll be mastering all the tools like R, Python, Anaconda, and R Shiny, Spark, etc. And it's getting really into mainstream. Developers, data science developers. Data science developers has data knowledge and then the data science related packages knowledge. You have analysts. Put a lady there, but it doesn't make any biasing towards the lady or a man. It's the people who analyze the data and creates report. And typically, they will be experts in visual analytics. So there is a certification called as certified visual analytics expert. That will be perfect for people who are aiming for analytics. They will be reporting to the senior management. They'll be getting data from the data science team, making it into nice, presentable pictures and 3D graphs, and easy reading format, that's more important, and share it with the management. We have researchers who actually find the sources, dig into the lots of different data sources and do experiments and try to get the data for the further processing in the data science. We have big data specialists who are actually experts in the big data related things. Also, they are very good expertise in machine learning algorithms. We have seen like 10 or 11 algorithms. So they will be creating the models actually. And data science developers will be working very closely with big data specialists. We have business persons who actually create the business questions which needs to be answered by the data science team. They know where to get the money, what are the right questions. And of course, we have infrastructure engineers. These are the people who are making sure all the servers and everything, they are like mostly infrastructure engineers. The only difference is they are managing data science related things. So it is little different. So we will tell you how it is different because it has to, availability may not be a huge problem here, which used to be the problem for the other infrastructure engineers. Here, effectively creating the infrastructure with a minimum expense and to execute large volumes of data. You should be very high in memory because when you're processing a data, the memory consumption is very high. So they will have a different kind of knowledge in terms of architecturing and also maintaining the infrastructure which is used for the data science. And of course, the data scientists who have overall all the knowledges, they will drive the data science projects. So they have all the knowledge on the higher level. They may not be doing it directly, but they will be actually visualizing and guiding all the team, getting the data science project successfully executed. Okay. All right. Any questions in this? So these are the different roles. So you can aim for certain roles based on your profile, and you can also sync with me afterwards to understand which role fits better to you. Training and certification. The key highlights in the training what we provide is we provide both the channels of training, traditional classroom and instructor-led online training. Sometimes a combination of it, right? So there are certain aspects which is only possible to do it with a physical face-to-face interaction so that we can have a hands-on help support for the participants, and most of the things can be done online. So given the location and other things, you can choose whatever channels we have. We have flexibility of providing both classroom training and online training. And we are the only one, I would say, in the market who are really dealing with 11 plus machine learning algorithms hands-on in R and Python. Right? Globally, we are the very few companies, I don't remember any other companies doing it, but we thoroughly discuss all the 11 algorithms in detail so that the participants can use the right algorithm whatever required for the for the business in their careers, in the job roles. And also while cracking interviews, there will be no corners which you don't know, because we cover all the algorithms in machine learning. Visual analytics with Tableau will provide hands-on training on visual analytics. You will also download and install Tableau 30 days free trial, and you can do all the exercise files I'm doing in my system. So you'll get a hands-on experience. Tableau itself is a huge job opportunities both in US and India, across the globe. US is crazily paid job. Right? Watch out for it. If you're planning to move to US, Tableau is one of the skills you might have to have it on your portfolio. So we have hands-on training for all the participants with all the tools I have discussed before. And we have 15 plus use cases and one live project. Live project is for the certified data scientist participants. But if others wants to get hands-on experience, they can actually request and get the access for the live project as well. And we have recently started exclusive career guidance, senior professionals helping you to find a job. So they actively look for jobs and send you updates. And we call it as PAT team, Placement Assistance Team. So certification, one mainstream certification is you have Data Science Foundation, which is 2 days classroom training or 5 days online training, which goes through all the concepts, whatever we have discussed now in more detail, higher level, but a little bit more detail than the demo sessions, so that you have an overview picture of what is data science. So this becomes a primary requisite for the next level, which is data science practitioner. Data science practitioner is for the people who wants to become a machine learning expert. So they talk about all the algorithms in detail, hands-on. It is 25 days training online or combined with the classroom. And the final thing is data scientist. So certified data scientist. And certified data scientist, in order to do that, you have to pursue the foundation and the practitioner before moving to the certified data scientist. After you do the practitioner, you already have all the statistical programming algorithm knowledge. What we add in the certified data scientist is the business knowledge. Business knowledge for a particular domain, or maybe a general business knowledge to model a data, to formulate the right business question. The focus on the certified data scientist to become a real scientist. If an organization comes to you with a problem or idea of making their data more useful to the company, you should be able to take it, mold it, create a model, and implement the model for the company. So to become that extent, you should also be domain or business expertise. It could be a specialized on particular domain or in a general perspective. That is what the focus on data scientist. Data scientist certification also mandates as live project. So once you complete the live project, you will get a final certificate that you are certified data scientist. It will take, the class is 1.5 months, but it will take 6 months to actually get the certification done. And we work with IBAC, International Association of Business Analytics Certification, to provide the certification. They are the central body, apex body for data science certifications. We have other certifications like certified data science developer, certified visual analytics expert, machine learning expert, web analytics, which is a huge opportunity. We have domain related expertise like HR, marketing, healthcare, etc. Reality is real estate. You can discuss with your counselors about which is more suitable for you. So I normally suggest the main track. Go with the certified data science foundation, data science practitioner, and certified data scientist. Okay, so we are done. Fantastic. Any questions for me? Questions and answers session. I'll take one by one. You can also unmute and ask questions. Good question. Can I master data science in 1.5 months? Very good question. Really depends on your capability. I cannot say yes or no. It really depends on person to person. But in general, I don't think you will master. Master is a very overstatement, right? You will get a hang of it. Right? The training will be complete. Then you need to practice by yourself. You have all the knowledge and tools and the tools expertise and the data sets, where to find data sets, but you need to practice for at least 4 to 6 months and do several live projects or several projects by yourself. We will provide you assistance if you need as required. At some point of time, you gain a bit more knowledge after 4 months or 5 months. You will be more confident. Getting mastery is maybe few years, but that doesn't stop you to getting a job. Even if you complete the data science course, you might get into a job because you can basically clear all kinds of questions and answer all kinds of questions, right? But you cannot call it as mastery. Mastery will take, sometimes it is just a journey, right? So to answer your question, yes, 1.5 months you will be thorough with all the concepts so that you can clear the interviews and you can perform the job, your job in your company. As we keep on doing it over a period of time, you will get better and better in your job. Did I answer your question? Yes. Thank you. Thank you, Karthik. Okay, I'll wait for the question. Please. I answered this question. What are the prerequisites for the courses? I already answered. If you just go back one slide, these certifications, I might be more, right? Most of the certification have this one as a prerequisite. This is prerequisite for all the certifications. You have to do the data science foundation to do anything else, any certifications over here. And for practitioner, this is a prerequisite. For certified data scientist, this is a prerequisite. And this is as per your IBAC, International Association of Business Analytics certification. But if you want to just pursue without certification, you are free to pursue any of these courses. Only training. Okay? Does it answer your question? All right. Thank you. I'll go back to the question and session. All right. Very good question from Reena. Right. So, what are the job opportunities? I have made another blog. I have written a blog which clearly talks about how huge the opportunities in data science. There are about easily 200,000 jobs available in US, which is yet to be filled. There's a huge gap for data science professionals. That is just US alone. Across the globe, I don't even know the number. But you can just put your resume, just if you want to test it. I don't recommend that, but after completing the course, maybe with the business analytics few keywords, you will start getting calls just like that from most of the companies, because there is a huge requirement for data science professionals, and this gap is going to go bigger and bigger because all the companies are getting into data science. There is no other way to become sustainable in the market and survive. Actually, you need to get data science into the companies, into the organizations. How do you get it? You need to get the right professionals in the organizations. So that actually is creating a huge gap between the skill sets available in the market and the opportunities. We have huge opportunities. You can trust me on that. And we have a PAT. If you have more data, if you need more data, you can ask the PAT, the placement assistance team, they will provide it. Okay, so then another question from Karthik again. So he's asking how much programming skills I need for doing this data science. I would say minimal. And even if you don't know any skills, you can learn the data science programming, just a bunch of commands and how you use it. It's not going to throw any errors. So it is almost like if you give certain parameters to a function, it will give you the result. So you don't have to be developer if that was your question. Okay. All right. So any more questions? Yeah. Okay. This is answered already. So job opportunities, you find it there's a lot of opportunities. If you need reports, you can get in touch with PAT team. Any questions relevant to data science? Technically, you're all qualified. Yeah, I'm qualified. Okay, you're all qualified. That's for sure. Which certification depends. For data science foundation, everyone is qualified. If you want to become a data science visual analytics expert, you need to have certain experience or exposure. But even if you don't have it, you are qualified to attend the course. Then you need to practice a little to become more visual analytics expert. That's a very good career opportunity as such. You directly work with senior management. Okay, thank you all for attending the session. So you have my details at the bottom and the contact points. Any further questions, you can feel free to contact me, drop a mail. I will definitely respond. You can get my number from your contact point. I'm not supposed to share it here. And you can obviously call me if you have further questions. Hope you enjoy the session. Any questions? Final questions? No? Thank you. All right. Have a great evening. It was a pleasure spending an hour with you, touring around data science concepts at a very high level. All right. I hope to see you around soon. Have a great day. Bye-bye. Thank you.